Hello students, in this video I am going to teach you objective questions from complex number. The second half, okay, first half already in the previous video I taught. Those who didn't see that one, you can watch that video. Question number 1 to 15 I taught in that one. So here 16 to the remaining, okay. So for that, some of the things what you need, some important results we discussed, then after that we go for the sums. The first one is how to write modulus and amplitude of a complex number. There are different ways you can denote a complex number, right? Complex number, the standard form, a plus ib, right? Then you can write it as a coordinate in organ plane to plot x comma y, like that you can write the complex number. Also in polar form, that's one of the very important area. The complex number a plus ib can be written in the form r into cos theta plus I sin theta. So like this also you can write the complex number. Here r is the modulus. R is the modulus, the formula root of a square plus b square. You can find it very easily. But normally students find difficult in finding the argument, right? Theta is the argument, or another name amplitude. To find the argument, first you find alpha. Alpha is equal to tan inverse modulus b by a. A is the real part, B is the imaginary part. Modulus, so take the positive value. You can find alpha value. Once you find alpha value, we want to find what? Theta. So depends on which quadrant it lies. Suppose the complex number is in the first quadrant. How can you identify that? You see the sign of A and B. Real part, imaginary part. Real axis, imaginary axis. When both are positive, it is the first quadrant, right? In the second quadrant, real part is negative, imaginary part is positive. Third quadrant, both negative, right? X value negative, Y value also negative. Fourth quadrant, positive, negative, okay? So first quadrant, second quadrant, third quadrant, fourth quadrant. If the complex number lies in the first quadrant, theta is equal to alpha. If it is in the second quadrant, it is pi minus alpha. Third quadrant, alpha minus pi. Fourth quadrant minus alpha. This is how you have to find theta using alpha. So to find the argument, first you find alpha using the formula tan inverse modulus b by a. Then you see the complex number is in which quadrant. Based on that, you will select the formula to find theta. If it is first quadrant, theta equal to alpha. Second quadrant, theta is pi minus alpha. Third quadrant, alpha minus pi. And in the fourth quadrant, minus alpha. And some of the standard forms you have to remember. The polar form of 1 minus 1 I minus I, that you remember. 1 is cos 0 plus I sin 0. Minus 1 is cos pi plus I sin pi. I sin pi. I cos pi by 2 plus I sin pi by 2, and minus I is cos pi by 2. Cos minus pi by 2. Cos minus pi by 2 plus I sin minus pi by 2. Cos theta plus I sin theta, in short you can write cis. Cos plus I sin. Here the argument is 0. That is cos pi plus I sin pi. Next one is cis pi by 2. Then cis minus pi by 2. So remember, for 1 it is 0. Minus 1 it is pi. For I it is pi by 2. Minus I it is minus pi by 2. Okay, so these things you remember. Then the next one you need De Moivre's theorem. That is cos theta plus I sin theta raised to n. Cos theta plus I sin theta. It should be in that form. Cos theta plus I sin theta raised to n can be written as cos n theta plus I sin n theta. Okay, that you remember. Then the main thing, you need the cube roots of unity. A lot of objective questions they can frame using cube roots of unity. Cube roots of unity are 1 omega omega square. 1 omega omega square. Remember the value of omega. Omega is minus 1 plus I root 3 by 2. Omega square value minus 1 minus I root 3 by 2. You may wonder, but if you square, you will get this value only. Okay. And two important results here. omega cube is equal to 1. When omega represent cube root of unity, omega cube is 1. 1 plus omega square is equal to 0. Omega cube is 1 means if the power is a multiple of 3, then the answer is what? 1. Omega cube is 1, omega raised to 6, omega raised to 30, the answer is 1. 1 plus omega square is 0. So from here, if I want omega plus omega square, you can write it as minus 1. If I want 1 plus omega, it is omega square and so on. All these results are true only when omega represent cube root of unity. Omega is not a fixed value like I equal to root of minus 1, right? But omega is this value only when omega represent cube root of unity. Omega may represent fourth root of unity. Omega may represent nth root of unity. Okay, so it takes different values. When omega represent cube root of unity, you can use all these values. Okay, so with this idea, we are going to do rest of the sums. Okay, now sum number 16. The principal argument. So in argument, one thing you remember, like log. So argument of Z1 into Z2. You know log of AB. Log of AB can be written as log A plus log B, right? So here you can say argument of Z1 plus argument of Z2. Argument of Z1 by Z2. You know log of A by B, log of A by B, quotient rule. You can write log A minus log B, right? So here you can say argument of Z1 minus argument of Z2. Argument of Z raised to N, power rule, log A raised to M log A, right? So same thing here also you can write N into argument of Z. Almost argument follows the rules of logarithm, right? It is just for you to remember. Now listen, look at this question. The principal argument of 3 by minus 1 plus I. It looks like log of A by B. So you can write it as argument of 3 minus argument of minus 1 plus I. So please listen carefully. For the first one, argument of only the real part is there. So when you find alpha, tan inverse modulus B by A. B by A means 0 by 3. It is 0. Tan inverse 0, so it is 0 only. Minus for the next one, plus minus and all there. So find alpha, tan inverse B by A. Modulus we take. So 1 by minus 1. So modulus minus 1, it is 1. So it is 45, pi by 4. See the quadrant, x value negative, right? Minus 1 plus I. X value negative, y value positive. So it is the second quadrant. Second quadrant, pi minus alpha. First quadrant, alpha. Second quadrant, pi minus alpha. Third quadrant, alpha minus pi. Fourth quadrant, minus alpha. Repeatedly you say and practice so that you won't make any mistake. Okay, so here pi minus alpha. So you have to write pi minus alpha. Alpha pi by 4. So 4 LCM, 4 pi minus pi, 3 pi by 4. So the answer is minus 3 pi by 4. That is option number 3. Okay, so hope you understood this one. Now let's move on to the next question, question number 17. Yes. The principal argument of some complex number given, power 5. So you can apply De Moivre's theorem, but if you want to apply De Moivre's theorem, it should be of the form cos theta plus I sin theta. So change it into cos. Sin 40 can be written as cos 90 minus 40. It is 50. Plus I into cos 40 can be written as sin 90 minus 40. It is sin 50, the whole power 5. Now cos theta plus I sin theta raised to n type. Apply De Moivre's theorem, the 5 comes front. So cos 5 into 50, it is 250 plus I sin 250. But the 250 is not in the answer, right? Argument. But you see 250 means, please listen, angle you start from here, the positive direction. So 90, 180, then 250 means another 70, right? So this is what? This full angle is what? 250, right? But if you go in this direction, please listen, this is 70, so this is a balance 20, right? Full angle is 90, no? So 20. Then here you have a 90. So 90 plus 20 is 110, but we go in the wrong direction, clockwise direction, so you have to put a sign minus. So here the principal argument is minus 110, option number 1. Sum number 18, if this is equal to x plus iy, then they asked to find. Here the method is you take the modulus. First you take the entire modulus. Here's an objective question, just very short you can do. If they ask some 3 mark, 2 mark question, you write the steps. First you take the whole modulus, then you split it. For every term you take modulus. Okay, you take modulus. So modulus means root of 1 square plus 1 square 2, root of 1 square plus 2 square 5, root of 1 square plus 3 square 10, and so on. Last one, root of 1 square plus n square is equal to root of x square plus y square. To avoid the root, you square it. When you square, you will get 2 into 5 into 10 into etc. into 1 plus n square. That only they ask, right? So rise it also square. You will get x square plus y square. So it is option number 3. It's a very simple question. Now listen, sum number 19. Omega not equal to 1 is a cube root of unity. Omega is a cube root of unity. A plus b omega is equal to 1 plus omega raised to 7. Please listen here. Cube root of unity already given the results. Omega cube is 1. 1 plus omega square is equal to 0. Here we have 1 plus omega can be written as minus omega square, the whole power 7. Minus 7 times, so it is minus omega square raised to 7. A raised to m, the whole power n is a raised to mn, so omega raised to 14 you will get. You know omega cube is 1, right? Nearest to 3 multiple omega raised to 12 into omega square. This is 1 into omega square, so you are getting minus omega square. And that minus omega square can be written as 1 plus omega, right? Can be written as 1 plus omega. So we have started with a plus b omega. Both the sides you compare now. Instead of a, what do you have? 1. So from here you can compare a equal to 1. And the coefficient of omega you take. Here coefficient of omega is b. Here coefficient of omega is 1. So you are getting a value 1 and b value also 1. So a comma b, it is 1 comma 1, option number 4. Now listen again, sum number 20, the principal argument of this. So again remember log a by b, log a minus log b, log a raised to m log a. So you can write 2 comes front. So 2 into argument of 1 plus I root 3 divided by, so put minus argument of 4i. Then another term is also in the denominator, so put minus argument of 1 plus I root 3. Now we find the argument of every term and substitute. See, this is 2 into tan inverse, both plus only, no? b by a, root 3 by 1, it is root 3. Here 4i, right? 4i, imaginary part is there, right? Tan inverse b by a. 4 by a value what? 0. So infinity you will get. Tan inverse infinity is what? 90, right? So minus is there, so it should be 90. Tan inverse infinity you get. Minus, next one, 1 minus, not plus, 1 minus I root 3, right? So 1 minus I root 3, if we simplify, alpha value find out, tan inverse modulus of b by a, tan inverse root 3, so it is pi by 3. See which quadrant it is. X value positive, y value negative, fourth quadrant means minus alpha, so minus pi by 3. So minus pi by 3, already a minus is there. So you are getting 2 into, this is pi by 3. Minus pi by 2, minus and minus plus pi by 3. First and last you group, if you group 3 is LCM, 2 pi plus 1 pi, it is 3 pi by 3 plus pi by 2. So not plus, it is minus pi by 2. So here 3 cancel. So pi minus pi by 2. Pi minus pi by 2. Take 2 as LCM. 2 pi minus pi. So your answer is pi by 2 and that is option number 4. Okay. Now look at the next question, 21st one. Alpha and beta are the roots of this equation. So one equation given, x square minus x plus 1 equal to 0. You solve this first. You will get 2 answers. Take one as alpha, another one as beta, right? So a value 1, b value minus 1 and c value 1, right? So these are the values you are getting. Now x equal to, we use the formula minus b plus or minus root of b square minus 4ac by 2a. So remember all the formula what you studied in the lower classes, right? Minus b, so 1 plus or minus root of b square 1 minus 4 into a1 c1. So by 2a, 2 into 1, 2. So you are getting 1 plus or minus root of minus 3. So root 3 into I you can write by 2. So two values you are getting. One is b value is 1, right? B value is 1. B value 1. So minus b means it should be minus 1. So you are getting two values, minus 1 plus I root 3 by 2. Another value is minus 1 minus I root 3 by 2. By seeing this, immediately it should come in your mind, this is actually omega. Minus 1 plus I root 3 by 2 means omega, and this is what? Omega square. So alpha and beta are the roots. Now we know omega and omega square are the roots. So instead of alpha, you write omega. For beta, you write omega square. So now the question reduced to omega raised to 2020 plus omega square raised to 2020. Hope you understood. Alpha and beta are the roots, but when we solved, we saw the roots are omega and omega square. So instead of alpha, you put omega. For beta, you put omega square. So omega raised to 2020. So that 2020 you divide by 3 table. 2020 you divide by 3 table. 6 3s are 18. Balance 2 22. 7 3s are 21. 1 0. 3 3s are 9. Balance 1. So omega raised to 673 into omega. So this is actually omega. Second one, this is actually you are getting omega raised to 4040, right? You have to multiply these two, 4040. Divide by 3 table, 133, then 10, 3 3s are 9, balance 1, 14, 4 3s are 12, then 2 0, 6 3s are 18, balance 2, right? So this will become omega raised to 2. So omega plus omega square is minus 1, because you know 1 plus omega square is equal to 0. So your answer is minus 1, that is option number 2. Listen the next question, question number 22. The product of the 4 values of this. So here first you apply, this is how the day cos theta plus I sin theta raised to n, right? The 3 you bring it front, so 3 comes front, so 3 cancel, right? So you are getting cos pi plus I sin pi raised to 1 by 4. So fourth roots, you are supposed to get 4 values. So while solving an equation, when you find the nth roots, there are 4 steps you have to remember. First you change it into polar form. Then add 2k pi to the argument. Apply D Movie's theorem. Then k variation கொடுங்க. If it is 4, you write 0, 1, 2, 3. So these are the 4 steps you remember when you find the nth roots of a complex number. Here you are finding 4th root of a complex number. The first step, we change it into polar form. Here already it is in polar form only. Second step, add 2k pi to the argument. So cos, you add 2k pi. So 2k pi plus I sin 2k pi plus pi raised to 1 by 4. So 2 steps over, right? Change it into polar form, add 2k pi to the argument, apply D Movie's theorem, cos theta plus I sin theta raised to n is cos n theta plus I sin. 1 by 4 will come front, so by 4. So cos 2k pi plus pi by 4 plus I sin 2k pi plus pi by 4. If it's an objective question, you don't need to write the steps and all like this. Just you can write this short, you can write. Okay, now k variation, k equal to 0, 1, 2, 3. If it is 4th root, 4 values, you are starting from 0, right? So 0, 1, 2, 3. Suppose the 10th root, 10 values, you are starting from 0, so 0, 1, 2, 3 up to 9. Okay, so nth root means 0, 1, 2, 3 up to n minus 1. So if they ask the values, that's all the values. So we find all the values because we have to find the product, right? So first you put k equal to 0. So when you put k equal to 0, what you get, I'm writing short. Cis k is 0, so cis pi by 4, meaning cos pi by 4 plus I sin pi by 4. You put k equal to 1, cis 1 you give, so 2 pi plus pi, it is 3 pi by 4. Then when you put k equal to 2, 2 2s are 4 pi plus pi, it is 5 pi by 4. When you put k equal to 3, you are getting cis 7 pi by 4. So these are the values. They asked to find the product. So to find the product, multiply the modulus. Here modulus values are all 1 only. So 1 into 1 into 1. But add the argument. So cis, add the argument pi by 4 plus 3 pi by 4 plus 5 pi by 4 plus 7 pi by 4. You try to simplify this. So you are getting cis 4 is LCM. Numerator if you add, you will get 16 pi by 4, right? So 4 table you cancel, you are getting cis 4 pi. 4 pi is equivalent to 0 because pi means 180. 2 pi is 360. 360 is equivalent to 0. So 2 pi, 4 pi, 6 pi, all these 0. So it is cis 0, meaning cos 0 plus I sin 0. Sin 0 is 0, so that part fully 0. Cos 0 is 1, so the final answer is what? 1, and that is option number 3. Okay, now just few more questions. Question number 23. In omega, omega not equal to 1 is a cube root of unity. This is equal to 3k. They asked to find k value, right? They asked to find k value. So here the easy method is, 1 is there. Second row, see the answer. Answer is not in omega, right? The question is in omega, but in the answers you can see it is not in omega. So what we do here, first row is first row plus second row plus third row. So if you add, what you get, you see 1 plus 1 plus 1, it is 3. Here if you add all these, 1 and minus 1 cancel, minus omega square plus omega square cancel 0. Third one, if you add 1 plus omega square plus omega, so it is 1 plus omega square, so you know the answer is what? 0. So that is also 0, so the calculation will be easy. Remaining you write as it is 1. Here you see minus 1 minus omega square. You know 1 plus omega square equal to 0. So omega is equal to minus 1 minus omega square. Here we have like that only, no? Minus 1 minus omega, so that can be replaced by omega. Remaining you write as it is 1 omega square omega equal to 3k. 3k, this is what given. Left side you simplify 3 into, leave the row and column, omega into omega, omega square, minus omega square into omega square means omega raised to 4 will come. That is omega cube into omega, omega cube is 1. So you are getting omega, right? Equal to 3k. Both the sides you cancel 3, so you are getting k equal to omega square minus omega. But in the answer, it is not given in terms of omega. They simplified. So you must know the value of omega square. Minus 1 minus I root 3 by 2. Minus omega is minus 1 plus I root 3 by 2. Take 2 as LCM. Minus 1 minus I root 3 by minus I root 3. Here minus into minus is plus 1 minus I root 3. So plus 1 minus 1 cancel. Minus I root 3 is minus 2 times I root 3 by 2. So 2 cancel. You are getting minus I root 3 is your answer. Check the options. Yes. Fourth one, minus root 3i. That I must come outside. Okay. So you have to remember the values of omega, omega square. Now listen, sum number 24, you see, raised to 10. First we try to simplify this part. Okay, 1 plus root 3i by 1 minus root 3i. To simplify, you multiply numerator and denominator by the conjugate of denominator. So multiply by 1 plus root 3i by 1 plus root 3i. So denominator you will get a square plus b square, that is 1 plus 3. Numerator you multiply term by term, so 1 by this 1 you multiply, or a plus b, the whole square, right? Any method, or term by term you multiply. 1 plus root 3i. By this root 3i you multiply, so you'll get root 3i. Then first and last do carefully, plus into plus it is plus, root 3 into root 3 is 3, I into I is I square, that is minus 1, so minus 3 you will get. So you are getting minus 2 plus 2 times I root 3 by 4. Take a 2 outside and cancel. If I take a 2 outside, minus 1 plus I root 3 by 4, cancel by 2 table, you are getting minus 1 plus I root 3 by 2, right? I root 3 by 2. You know, this is actually same as minus 1 plus I root 3 by 2 is what? Omega, right? When you simplify this part, you are getting omega. The power is 10. So you are getting omega raised to what? 10 you are getting, right? So you have to find the, what they asked to find? The value of this they asked, omega raised to 10. So you have to find omega raised to 10. Omega raised to 10 means it is omega raised to 9 into omega. So omega raised to 9 is 1. So you are getting what? Omega. You are getting omega. But they change that in terms of what? Polar form. So omega means, you know, it is minus 1 plus I root 3 by 2. The polar form, you remember the magnitude will be 1. You can split into 2, then A plus IB form. You can write R into cos theta plus I sin theta. R equal to root of A square plus B square. R given, you find alpha first, tan inverse modulus B by A. Then theta you can find, depends on which quadrant it is, right? But there is an easy method. For nth root, please remember this result. For nth root, the argument is 2 pi by n. For nth root of unity, when omega represents nth root of unity, the argument is 2 pi by n. If you remember these results, you can save a lot of time. So you must know the direct method. If it is a 2 mark, 3 mark question, you need the steps, right? For objective question and for competitive exams, nth root of cube root of unity, the argument is 2 pi by n. Here cube root, so instead of n you put 3. So the argument is theta is equal to 2 pi by 3 will come, and magnitude will be 1. It's a cube root of unity only, right? So the polar form is cos 2 pi by 3 plus I sin 2 pi by 3, or in short you can say cis 2 pi by 3, and that is option number 1. Okay, now let's move on to the last question. Omega is equal to cis 2 pi by 3. See, just now we did that, right? Cis 2 pi by 3 means it is the cube root of unity. So that means here omega represents cube root of unity. Instead of giving the sentence, they given like this, okay? Cis 2 pi by 3 is, that is the polar form of cube root of unity, omega, right? The distinct number of roots, the number of distinct roots. How many distinct roots are there? So it is an equation in Z, right? So how many values Z can have? That's the question. First, we try to simplify this determinant. For that, R1 is R1 plus R2 plus R3. Remember, 1 plus omega square is 0. If you add all the three, 1 plus omega square is 0. You get only that Z. Here, if you add 1 plus omega square is 0. You get only Z. Here, you get 1 plus omega square is 0. You get only Z, right? Remaining, you write as it is. Omega Z plus omega square 1, omega square 1 Z plus omega. Now in the first row you can take Z common. So take Z outside. So Z, if you take outside, you will get 1, 1, 1. Remaining omega Z plus omega square 1, omega square 1 Z plus omega equal to 0. Whenever you see 3 ones like this, you make 2 of them zeros. So Z into first column you write as it is. Second column minus first column. Second column is second column minus first column. So 1 minus 1, 0. Here Z plus omega square, then minus omega, right? You can't simplify. So Z plus omega square minus omega. Then here 1 minus omega square, right? 1 minus omega square. C3 is again C3 minus C1. C3 minus C1. C3 is C3 minus C1. So this minus this. So again 1 minus 1, 0. 1 minus omega Z plus omega minus omega square. Now just to simplify, see Z into 1 into, leave that row, that column, this minus this. All the remaining will be 0. But this is a tedious work, right? Here 3 into 3, 9 terms you will get first. Second one 2 into 2, 4 terms. So 9 and 4, 13 terms you will write, okay? So you are getting Z plus omega square minus omega into Z plus omega minus omega square minus 1 minus omega square into 1 minus omega equal to 0. So now you simplify Z into, by this Z you multiply, you have to practice it. The sums which looks little lengthy one you find difficult, don't leave it. Do that again and again, 2-3 times you write and get confident in that one. Suppose the same question, if they ask us a 3-mark question compulsory, what will you do, right? You have to write the steps. So write and practice. So by this Z you multiply all the 3, Z square plus Z omega minus Z omega square. By the second one, omega square you multiply. Remember, omega cube is 1, omega raised to 4 is omega, right? Okay. So omega square into Z. So plus Z omega square plus omega cube, you write 1. Then you will get minus omega raised to 4, it is omega. Now come to the last one, by this minus omega minus Z omega minus omega square, then minus into minus is plus omega cube, that is 1. So this part we multiplied. Here you multiply these two, outside there is a sign minus. So the first you multiply by this minus 1 into this part, okay. So minus 1 into 1, you get minus 1. Then minus 1 into minus omega plus omega. Next one minus into this minus is what? Plus. So by omega square you multiply. Omega square into 1, omega square. Then you are getting what? Minus omega cube. Minus omega cube means it is what? 1 equal to 0. Now try to simplify this. See what you can cancel. Plus Z omega minus Z omega minus Z omega square plus Z omega square. Then minus omega plus omega square minus omega square minus 1 plus 1. Then here 1 plus 1 minus 1. See what you have? Everything cancel except that Z square, right? Z into Z square equal to 0. You are getting Z cube equal to 0. It's a cubic equation. You are supposed to get 3 values, but all the 3 values will be same, right? So Z equal to 0, 0, 0. Question is how many distinct roots? So even though you are getting 3 roots, all the 3 are same, right? So no distinct root means just you say only one distinct root, okay? So a lot of calculation. So practice all these things, okay? Hope you understood all these things. Learn all the concepts, then work out the sums. Definitely you can do the sums, okay? We'll continue in the next video.